So today we are factoring polynomials completely. So the reason that word completely is in there is because we're going to get these large polynomials that we're going to have to find the greatest common factor, or maybe there's factors within. Here's our very first directions, which is factor the expression. And what we are factoring is 4x times the quantity x minus 3 plus 5 times the quantity x minus 3. Okay, get that down. And now what I wanted to point out is x minus 3 is repeated in both parts. So I just called it a, and I wanted to show you how it's similar here to something we've already done. Say we have 4x times a plus 5 times a. If I told you to factor it, you would then pull out the greatest common factor, which is a. That goes in front, and what's left is that 4x plus that 5. So it's no different here. Now we're just factoring out a binomial. So you have x minus 3 in common in both cases, so you're factoring that part out. And what is left is that 4x plus 5. And that's it. Your answer is there. It's done. Check. Okay, number 2. You have 2y squared times the quantity x minus 5 minus 3 times the quantity 5 minus y. Get that down, and let's see, can we factor out this term? Is there anything the same? Well, you can see it here. I wrote it's not the same because here you have y minus 5. So y is positive and negative. 5 is negative. Here I have 5 minus y, so y is negative and 5 is positive. So it's like the opposite. So if I want to turn these into the opposite, I can multiply this part by negative 1. But that would change the whole relationship. So I also have to multiply this by negative 1 because negative 1 times negative 1 is still a positive, so it's still allowed. So if I multiply negative 3 times negative 1, I get positive 3. And negative 1 times 5 is negative 5, and negative 1 times negative y is positive y. Now I've got 5 minus y, which essentially is the same thing as y minus 5. Sorry, y minus 5 is the same thing as negative 5 plus y. So I could rearrange that to plus 3. And instead of 5 minus y, I now have a positive y and a negative 5. And now I can factor out y minus 5 from both. And what remains is that 2y now plus 3 because I multiplied that by negative 1. So this is what we have now. So this is like no longer exists. I have a plus 3, and that's why that's there. All right, cool. So now we get a bit further into this lesson. Factor the polynomial. Number 3, I've got x cubed plus 2x squared plus 8x plus 16. So I've got 4 terms here to work with. So that's what we're going to see a lot of cases like this is 4 terms. My first 2 terms are x squared and 2x cubed and 2x squared. I'm going to work with those individually. And then I have plus 8x plus 16, and I'm going to work with those 2 initially. So I'm looking at just these 2 terms, x cubed and 2x squared. I'm going to factor out my greatest common factor just between these 2 terms. So x cubed and 2x squared, the most that I can factor out would be an x squared. When I factor out an x squared from x cubed, I'm left with an x. When I factor out an x squared from 2x squared, I'm left with 2. So now I'm left with x times 2x plus 2 on the first 2 terms. The second 2 terms, I want to get this x plus 2 again. So I got to think, how could I turn 8x plus 16 into an x plus 2? Well, if I factor out an 8, that's my greatest common factor anyway. I have an 8 times an x, that's 8x, and an 8 times a 2, that's a 16. So that works. Now, what's my greatest common factor between both of these terms? It's this binomial, x plus 2, times what's left, x squared plus 8. Okay? So this is what I do when I have this huge polynomial. Make sure you get that down, and that's my answer. Number 4, I've got x cubed minus 10 minus 5x plus 2x squared. Now, you can't move further until you put this in standard form. So go ahead and put it in standard form. Okay, almost done. It's all good. So when you put it in standard form, you get x cubed plus 2x squared minus 5x minus 10. That way, we can still continue to do this factoring business. So if I look at these first two terms, I want to factor out my greatest common factor. Oh, again, it's x squared. It's going to happen, right? And I'm left with x plus 2 again. That's just happened to be the problem I pick. So now I want that x plus 2 to repeat, so I got to factor out my greatest common factor here. This one's tricky because I've got negatives, right? So I have negative 5x minus 10. So I have to factor out, in order to get a positive x and a positive 2, a negative 5. Okay? And then when I factor out my x plus 2, I'm left with x squared minus 5. And now, because I have x squared minus 5, I need to look at that a bit further, because if I have the difference of two squares, I actually can break it down further, and you're going to see that in two examples. So, for example, if I had x squared minus 4, this does factor out further. It turns into x plus 2 times x minus 2. So I can take it further because this is a square and this is a square. X squared is obviously a square, and negative 4 is 2 squared. So that's why this works like this. It's one of those special cases of the difference of two squares. Now, number 5 is our next example. We have x squared plus 2x minus 1. If you notice, you can't factor this. It will not happen. And I just wanted to make sure you understood that that can't happen. There's nothing that you can multiply, right, to get negative 1 and positive 1, except I need negative 1 as my c value, and the only way to get that is to multiply negative 1 and positive 1. But when I combine these two, they cancel and I don't get a 2. So this is one of those cases that can't be factored. Yes, you can use the quadratic formula to solve for it, but that's not what we're asking. We're asking factor, and it can't be. So you're done. Number 6, last and hardest one here. We've got h, I use a different variable, change it up. H cubed plus 4h squared minus 25h minus 100. So again, it's in standard form, so we're good. I'm going to work with my first two terms. I'm going to pull out an h squared. What's left is h plus 4. Then my next two terms, I also want to pull out an h plus 4. The way to get that is to pull out my negative 25. Now I've got h plus 4 times the quantity h squared minus 25. And this is where most cases so far, at least, we've been done. But we actually can go further because my h squared minus 25 is the difference, meaning subtraction, of two squares. 25 is really 5 squared. H plus 4 stays the same, but h squared minus 25 can be factored. And you can look at it even using the asterisk method if you do that. A times c is negative 25. My b value doesn't exist. What multiplies to negative 25 and adds to 0? Well, that's 5 and negative 5. My a value is 1, so I get 1h plus 5 times 1h minus 5, which is my now answer, because I was only working with that one piece. That's it.